Hello friends, you are welcome to this training, Geographic Information System and Introduction to QGIS training. I am Idako Victor, a GIS specialist and an urban planner, and I will be the facilitator of this training today, and you are all welcome. Today in this training, like we said, it's the first day of the training. It's a 3-day training, and today is our first day. And this first day, we'll be learning what GIS is. We'll be introducing you to what GIS is. For those of us that are having the background on GIS, there are new things that will be here. I know you already have the idea on it, but we'll still be introducing you to the GIS platform, and we'll talk a bit about GIS. We'll also be talking about various applications of GIS. We'll also be talking about various sources of GIS data, and also at the end of today's class, we'll be downloading and installing QGIS. First, what is GIS? In its strictest sense, GIS is a computer system capable of assembling, storing, manipulating, and displaying geographically referenced information. What it means by geographical reference information are information that are tied to the surface of the earth, and this definition is by United States Geological Survey. Also, GIS is an integrated system of computer hardware, software, and trained personnel linking topographic, demographic, utility, facility, image, and other resources that is geographically referenced. And like I said, this is by NASA. GIS doesn't work with any data. The data must be geographically referenced. Should be tied down to a particular area on the surface of the earth for GIS to be able to use such data. So let's go to a short history of what GIS is, and we're talking about some of the concepts of GIS. One of the most famous early examples of GIS or spatial analysis was done by Dr. John Snow in 1854. Even prior to this time, GIS have been used, but this research, the research by Dr. John Snow, served as a groundbreaking research for GIS. And in the process, he went through studying, analyzing a cholera outbreak in London in 1854, and he discovered that there was a breakage in the water system, and the sewage system was dripping into the water system, causing cholera and deaths. So we've been talking about GIS. We've defined GIS. Talked about the short history. What can GIS actually do for us? GIS can be used as a tool in both problem solving and decision making process, as well as visualizing this data. Once you have the GIS can solve your problems, can help you in decision making, and once this problem are being solved and the decision making process is being done, you can actually see the problem being solved, or you can see the process in the map format, or can be displayed on the maps. So that is what GIS can do. And there are various areas in which analysis that GIS can help in solving problems. For example, location of features and relationship to other features. You can identify what is the location, where is the location of a particular feature. Let's say, for example, a bank, and the relationship to other feature, let's say customers. You want to know where is the location of the bank, and where are the customers coming from in relation to this bank. One can also talk about where the most or the least of such feature exists. You want to know where you have more boreholes, where you have more health facilities. You want to know where you have more of the population, or a particular group of persons. Where do they exist? Where we have least population, but in this place we have more population. In this place, GIS can help us in achieving that. We also want to see density of features. For example, we have density of human beings. You have where you have large population, less population. You want to also see density of trees, density of buildings, and you want to see density of health facilities, churches, mosques, and other facilities. GIS can enable you to do that. Also, you want to see what is happening inside an area of interest. For example, you in your village or in a particular locality, you want to know the activities that are taking place there, commercial activities, recreational activities, what are the health facilities within such area. GIS can help you in doing that. Also, GIS can help you know what is happening nearby. For example, you have a water body, you want to know what are the activities that are taking place close to the water body. GIS can help you in doing that. Also, GIS can help you in identifying changes over time. You can use GIS to see how a place, a town, a village, a settlement is changing, and which will help you in knowing how best one can decide on facilities, utilities, and services to be provided in such areas. Next is you have the concepts. We have diverse concepts where GIS is applied. Is it network analysis, incident mapping, spatial measurement, corridor selection, transportation modeling, logistic routing, resource exploration, facility management, geoprocess modeling, spread and diffusion, topographic analysis, demographic analysis, engineering design, site selection, watershed analysis, resource inventory, land management, and the list is endless in the various sectors in which GIS and areas GIS is used. So next we'll be looking at the various applications of GIS. There are over 1,000 GIS applications in 50 industries, over 50 industries, and the list keep building up because GIS is tied to location. Once there's a locational problem, GIS can be applied, and we'll be looking at some of those areas of applications like we have here in land use planning. GIS can be used in urban model development. GIS can be used in land use conflict identification, where to identify where we have conflicting various land uses, residential or commercial land. When a commercial land use is eating up residential area, or a residential area is eating up recreational areas, GIS can also help us in creating 3D view shades of a particular city. Also, land use change. GIS can help us in having changes in land use. Also, GIS can help us in determine future development. Once you see the pattern of existing of development in a particular locality, is it an urban center, is it a local village, is it a settlement, GIS can help us to determine future pattern of the area. Also, GIS is used in transportation, where we have active transportation planning, where you can bring different stakeholders. The population can also be participating in the transportation planning using geographic information system. GIS is also used in parking demand, estimating the demand. Using the numbers of cars flowing through a particular area, GIS can be used to estimate the demand of such in such area. Also, GIS can be used in bus routing and shortest path analysis to determine the shortest route, like Uber and that we have. Those of us that have used Uber or other transportation communication platform, we've seen how such platform have eased movement over time, and see how it can improve our movement. Also, GIS is used in road assessment. In using LiDAR technology, GIS have been used to identify or to assess the road network. GIS is also used in architecture, in areas of development planning, areas of geodesign, areas of pedestrian behavior. You want to study pedestrian behavior. The GPS location of pedestrian movement can be tracked, and the movement and the behavior can be mapped, and to see how best the pedestrian routes or the pedestrian system can be managed and the movement of people can be easy. Then we have GIS is also used in environment and groundwater, where we have environmental impact assessment. In surface water flow, GIS can be used in surface water flow assessment. GIS is also used in 3D borehole areas. We've discovered there are some areas that during dry season there are no water, so GIS can also help us to see at what depth can the boreholes be dug to get available enough water supply in particular area. GIS is also used in groundwater volume, determining groundwater volume, in determining land cover, land use. GIS is also used in estimating flood damage, areas that have been flooded and the damage caused by the flood. Also, GIS in recent time, GIS is used in the health sector, in health mapping, real-time global disease monitoring, like we have in the recent pandemic, the COVID-19. We've seen how maps are used to display the active cases and reduction in the cases and active deaths and the rest. Also, GIS is used in distance to healthcare facility, finding closest doctor or specific field. Once the facilities are mapped, the doctors are mapped, GIS can help you find where is the closest facility, the closest hierarchy or a particular area. Let's say, for example, a pregnant woman needs attention of a doctor. GIS can be used to map out the closest hospital or the closest specialized doctor in that area. GIS is also used in vital record keeping in birth and death, by keeping birth record, death record, maternity mortality rate, and the various records, and also in displaying them and making analysis with them. Also in disease surveillance, connecting dots of air pollution. In the case of asthma, in the case of ambulance response, there is an accident. GIS can also display closest ambulance response unit and also help the ambulance response unit to locate the shortest route to access such accident location. Also in recent time, GIS is used in cancer research, like we see in the map below. Also, GIS is used in studying crime patterns, incident mapping. When there's an incident, is it incident of burglary, is it theft, is it rape, and GIS can help us identify the patterns of this crime and know how best security personnel can be deployed to manage such incident. Also in emergency calls and dispatch, GIS is used in 911 calls in big cities like Abuja, Lagos. GIS have been used in emergency calls, and see how security emergency units can actually go when there's an emergency situation, can see how they can solve such problems. Also in recent time, GIS is used in forensic studies, where maps, imagery, satellite imagery are studied to see the patterns of events and know what actually caused a particular death case or a crime case, and to see how best they can solve such crime. So these are the various applications, the selected applications of GIS. The list is endless. You can go through GIS geography and you will have more information about various areas of application of GIS, even in the banking sector, even in business sectors, in agriculture. GIS is very much applicable. Next, we have the data elements of GIS. We have the geographic data elements and we have the attributes. The geographic data elements, these are location on the surface of the earth. Like we know in basic geography, we have location and we have what we call reference, where each location on the surface of the earth has its unique reference system. And so we have two GIS elements. We have the geographic and The non-geographic, like the geographic, tied, like I said, a tied location tied us to a particular location. Depends on what particular location we're talking about. And the non-geographic tends to explain what that location is. Let's say, for example, we have location of schools in a particular area. These are geolocation. Like, for example, we have this school here. The point location is showing us the actual location, which is the geographic. We have in geographic we have the x and y coordinates showing us the location of the school, while the non-geographic are the attributes. For example, we have the state code, source name, word code, category, and other information attached to this school. Okay, we clicked on two schools. Let's say this school. So these are the geographic and the non-geographic. Geographic talks about the coordinates, because the coordinate is a unique identifier. There's no place that have similar coordinate system. Everywhere has their own unique coordinate system. So the coordinate system or the coordinate point is the unique unifier. Then the attributes or the non-geographic tends to explain what that particular entity is talking about. So I haven't talked about the element. We have two vector GIS data model. We have the vector data model and we have the raster data model. Under the vector data model, we have points, polyline, and polygon. And under the raster data model, we have discrete and continuous. The vector data model, we have points. Point shows unique location of a particular area. Let's say, for example, you want to show the location of the trees, want to show the location of cars parked, want to show the location of features, schools like it was shown earlier. You can use the point to identify, like we have in the display where we have 3 trees and the points are shown, and like we said, each point has its own unifier, the coordinate, the x and y coordinates to show the exact location of a particular place. Then beneath it we have the polyline. The polyline shows it's the combination of connecting the connection of 2 or more points, like we've seen here. Polyline is the connection of 2 or more points, and polyline can be used to represent streams, road network, and rail lines and other features that are in line in nature. Then the last one on the list is a polygon. The polygon is a combination of points and polyline in an enclosed space. For example, polygon can be used to represent large water body, can be used to represent boundaries, local government boundaries, state boundaries, and other boundaries. For example, here we have the various. Here we have, these are the polygons of polygon data of different states in Nigeria. Then here, like we shown earlier, we have points of public schools in a particular state in Nigeria, and also here we have the road network of the entire country. So the road network, these are polyline. Polyline is used to represent the road network. Then the polygon is used to represent boundaries, state boundaries, and the polyline points rather is used to represent hospital. You can use primary public schools. You can use points to represent hospitals, location of buildings, and other features. It depends on the demand for such work. And these are the vector data structure. Then next is the raster data structure. We have the continuous and the discrete. Raster in GIS, any image that is geographically referenced, any picture that is geographically referenced is raster in GIS. And we have continuous raster and discrete raster. The continuous raster are raster that are continuous in nature, in the sense that the pattern of changes cannot be determined, like easily seen, like as a particular area change or image change, you can actually have a thin line or the extent of such change. For example, we have elevation data like we've seen here. We can't actually say this is the extent of a particular layer or display of the map. So that is the continuous data. While the discrete shows extent of different features on the image. Like we have red here, we have yellow, we have the green here, we have the blue here. These are the extent of the raster. And raster, these are the combination of every image shows or has vertical and horizontal line cells. It has a combination of cells arranged in vertical and horizontal, like as is displayed here. So that is the raster data. For those of us that are just joining us, you are welcome. And those of us that are just getting to know what GIS is, I know it might sound so big, but GIS is a simple component. As you progress, you tend to have detail about what GIS is, and in our next class and other subsequent classes, you get to have detail about what GIS is. The various, we spoke about vector data, and now we're talking about raster data. As we progress, you get to know what they are. The next is the coordinate system. We have in GIS, since we are talking about geographically referenced data, coordinate system cannot be hidden out of the picture, because the coordinate system is what determines or gives the unifier of a particular area. Like we have the geographic coordinate system and we have the projected coordinate system. The geographic coordinate system is the spherical or the geoid representation of the surface of the earth, and it's measured in angles. It's a three-dimensional representation of the spherical earth, and it's measured in angles. And the popular system, geographic coordinate system, is the World Geographic System of 1984. Like we have here, the typical representation of the surface of the earth. That is the geographic coordinate system. It sees the earth as a globe, and it measures in angles, and you can see features arranged in the spherical as a spherical earth. That is the geographic coordinate system. While the projected coordinate system is the breaking of the slicing of the geographic coordinate system onto a flat surface, and it is represented in easts and northings, x and y. And for those of us in Nigeria, the UTM in Adatum 2032 is the common used geographic projected coordinate system. And like it is shown here, we have the flat. You see, instead of having a spherical earth, we have a flat earth. So from the spherical earth, it's been broken or it's been converted into a flat surface. There are different methods of conversion, and we will not go into detail about them. We just want to introduce you to GIS and to tell you that we have geographic coordinate system and projected coordinate system, and what geographic coordinate system is all about, and what projected coordinate system is all about. Next, we'll be discussing the various GIS data sources. As a GIS expert, and those of us that are just joining us or getting to know what GIS is, in the course of your work, you will need to source data. So here we are presenting various GIS sources, where you can source GIS data and how you can download those data from. For example, let's start with the Diva GIS. The Diva GIS is a site where one can download data by country. Like we have the country, you can search. We have from Afghanistan down to Zimbabwe. Here we can download data, and the types of data that can be downloaded are administrative data, inland water, roads, railroads, elevation, land cover, population, and other data. So once you click on it, you can click OK, and you get your data downloaded. Also, you can download your data from OpenStreetMap, where we have various sub-regions, and from Africa down to South America. you can download, click on a particular region. We have other sub-region that are there you can download. Once you go there, you can download using different formats. In our subsequent classes, you'll be seeing, or will come here and download data and also bring them into our GIS environment. So this is the OpenStreetMap downloading site. Also, we have Ultra Humanitarian Data Exchange. For some of us that are in Nigeria, you can download this data from the site. We have Ultra Nigerian Data Humanitarian Exchange. You can click on data. We have various data here. We also have Ukraine subnational population statistics. So you can download data from Ultra Humanitarian Data Exchange. And also these are vector data sources. We have Google Earth. Also for the raster data sources, we have the USGS Earth Explorer. Here you can download raster image, but first you have to create a username, login, username, password, and login, and then source your data. In subsequent class, you will be taught how to download data from this site and how to use them in performing various analysis. Same with the GIS. You can also download population data and elevation data from the GIS. Then we can also download vector data from the Google Earth software. Here is the Google Earth software where it contains satellite imagery of any place portion on the surface of the Earth. You can zoom into a particular area and then download the imagery of that place, which is raster. Also, you can measure or bring out features of that area and then save them, which are in vector format. So this is the Google Earth, and you can also download the Google Earth from the internet. Just go to your browser and type Google Earth download, and you can follow the procedure there. Next, we'll be downloading the QGIS software. The QGIS can be downloaded using by typing using the link I displayed on our screen, and you can also Google type QGIS on your browser, QGIS download in your browser, and will also have the QGIS installed. So in the next video, you'll be seeing the procedure to download QGIS and how to install the QGIS also in the next video. So thank you very much.